Hey everyone, and welcome. We're about to dive into a really fascinating and honestly pretty radical idea that could totally flip our view of reality on its head. I mean, what if the entire universe, everything you see, all the stars, the planets, you, me, is actually just one single thing? To even begin to wrap our heads around that, we have to start with a really provocative question. We always talk about the laws of nature, like there's some kind of cosmic rule book that the universe has to follow. But what if they're not? What if those laws aren't external rules at all, but are just our descriptions of the patterns we happen to see? So, where does this whole new perspective come from? Well, it starts by identifying what it calls a fundamental flaw in the way we've been thinking for centuries. It's possible we've been approaching science, and even logic itself, from completely the wrong direction. And the core principle behind this is a really powerful one. We have this habit, we rush to define things, to separate them. This is an object, that's a number, this is an idea, without first stopping to ask a much more important question. Can we even make these distinctions perfectly? The whole argument is that this tendency to just ignore the limits of definition, well, that's where our thinking goes off the rails. And look, this isn't just some abstract philosophical idea. This pattern has popped up again and again throughout history. In logic, you had Russell's paradox, which showed that some collections just plain can't be defined without running into a contradiction. In math, Gödel came along and proved that any formal system is going to have true statements that it can't actually prove. And of course, in physics, quantum mechanics showed us this fuzzy reality where you can't always measure things with perfect precision. It seems like every time we build our understanding on the idea of perfect, separate things, we end up finding these weird paradoxes right at the edges. Okay, so if starting by separating things into little boxes is the mistake, then what's the alternative? Well, the answer is to just flip our thinking completely. We have to start from a totally different assumption, that everything is already connected from the very beginning. So you've got two ways of looking at the world. On one hand, you have the traditional view, right? The universe is this giant collection of countless separate things, planets, particles, people, and they're all following some set of external rules. But this one object view, it says nope. There's only one fundamental thing. Reality is a single continuous object, and everything we see, every particle, every star, is just a local property, kind of like a ripple or a bump in that one object. We only know things exist because we can measure the differences between them. And this shift in thinking, it has some huge implications. Suddenly, the universe isn't obeying some external laws, it's just being itself. It's behaving according to its own internal nature. And what we call scientific laws, they're just our limited human descriptions of those patterns we see. This even changes what it means to measure something. It's not a passive observation anymore, it's an active participation, an interaction between two different parts of the very same object. All right, so this is a really beautiful, elegant, philosophical framework. It's very neat. But does it actually hold up in the real world? Because it faces this enormous challenge when it smashes right into the bizarre, counterintuitive world of quantum physics. And let's be totally upfront about the problems here. Critics would say, this whole thing is really hard to test. You can't really prove it wrong. It can feel way too abstract. And let's be honest, science gets a lot of work done by separating things out and modeling them. But the biggest problem, the one that could stop this whole idea in its tracks, is that quantum conflict. How in the world does a single, smooth, continuous object manage to create all the strange, discrete, and just plain weird behavior we see in fundamental particles? And that question brings us to the ultimate test case, the property we call quantum spin. Specifically, a type of spin that seems to defy all classical, common-sense logic. If this one-object model can't explain this, then it's probably doomed to stay a philosophical curiosity forever. So what is this ridiculously strange property? We're talking about spin 1/2. It's a fundamental property of particles like electrons. And here is the absolutely wild part. If you rotate an electron 360 degrees, one full circle, it is not back to its original state. You actually have to rotate it another 360 degrees for a total of 720, two full turns to get it back to where it started. I mean, how could that possibly come from some simple continuous medium? It seems impossible. Okay, so this is the moment where the abstract philosophy has to try and become concrete physics. To bridge this enormous gap, the people behind this idea have actually developed a potential physical model for how this could work. And the proposed solution is this. You model reality as a single, continuous, elastic medium. Think of it like a giant block of Jell-O, maybe. But here's the absolute key. It's not uniform. The models suggest that a special two-layer structure can actually form inside it. And that's how we get things that look and act like particles. So how do you build a particle this way? Well, it's basically a two-step process. First, a stable, almost spherical shell forms inside this elastic stuff, and that acts as a sort of container. Then, for layer 2, inside that stable shell, a really complex pattern of resonances and movements gets going. And it's this internal dynamic, this band-Tetrick mechanism, that they propose is what actually generates that bizarre 720-degree symmetry of spin 1/2. Now, I know this might sound like a pretty clever analogy, but the model's proponents argue that it's actually grounded in some very specific mathematics. So let's take a quick look at the equations they say make this whole structure not just possible, but stable. So the stability of that outer shell, that first layer, it's modeled using a very specific mathematical tool. It involves combining two simple functions known as Legendre polynomials to describe a shape. What does this all add up to? Well, the math basically gives us a blueprint for a stable, particle-like structure that can emerge all on its own from this underlying medium. It creates this near-perfect spherical shape that is a stable home, a little pocket of minimal stress. And that stable foundation is what allows for all the complex stuff to happen on the inside, the resonances that give rise to the quantum property of spin. And all of this leaves us with one final, pretty provocative thought. If a model that's built on this idea of a single continuous reality can actually provide a potential mechanical explanation for one of the absolute weirdest properties in all of quantum physics, what does that mean? Are we maybe, just maybe, seeing the faint outlines of a completely new kind of physics? Now that is something to think about.